situation. It's not life or death if you get it right or not or anything, but this is a real thing. I want to construct two identical rectangles using 500 feet of fencing, so that means it's going to look something like that. You got a rectangle over here, a rectangle over here. Adjacent to each other, so they share fencing on one side, that's this side. You have 500 feet of fencing. And with that 500 fencing, you want to make this area as big as you can. Like, you want to enclose the biggest area you can. So, what are dimensions going to be? Like, that's an optimization problem. Let's try to maximize the area that we can get, given this restriction that we only have 500 feet of fencing or a certain amount of money to spend. Or like, that's what these are going to be. So, what we need to do is set up equations that relate the stuff we're looking at, and we're going to have usually two equations. One that is like a thing we know is true, and one that we're trying to maximize, which means we're trying to like make this as bigger or bigger or small as possible. So let's just start by, it's kind of hard for me to like get you to answer things because you don't really know what you're doing yet, so I'm just going to start doing it. Let's say I call this side x. Well then, isn't this side also x? And this side also x? And let's say I call this big side y. With that information there, with my drawing, and your drawings could be slightly different, like they could be sideways, your y-axis could be different. We'll all end up in the same spot if we don't do it right. Can someone give me an equation that I know is true based on what is written down right now? Lennox. 3x plus 2y has to equal 500. Perfect. I know that's true. So that gives me like a starting point. I got numbers here. I know this is like solid. This is the true thing. I can work with that. What am I trying to maximize or minimize? The area. What is the area of this giant rectangle? It's x times y, right? So the width of this rectangle is x. The length is y. So then what we do is we set up another equation and we say xy equals max. So we're going to try to maximize xy and make it as big as we possibly can. More like it, right?
I was just remembering a different assignment we did that was like this. That was really hard.
In pre calc?
Yeah. It was just like where you do two equations like this.
Oh, okay.
It was a flashcard.
So what I want, this is the equation I want to work with. I want to be able to max or min, whatever. The way I find max or mins is from which level. Which level tells you max and min? First derivative. So I want to be able to take the derivative of this. I don't want there to be two variables. So I'm going to turn this into one variable. So how do I do that? No. I can just name. That doesn't help. What's xg? This is two variables. No. These are garbage answers. Wait, maybe this is why no one talks about it. What else can I do? Yeah. Yeah. So couldn't I can do substitution. So I can take this equation, solve for one of the variables, and then take that and plug it in. So I only have one variable left. So I'm going to solve for, it doesn't really matter. We got a 2 and a 3, and 3 doesn't go into 500, so I'm kind of stuck. But let's solve for y. 2y is going to equal negative 3x plus 500. So then y is going to equal negative 1.5x plus 250. Fair enough? And the reason I care about this is now, instead of putting y in the other equation, I can put the negative 1.5x plus 250. So now I get down to, okay, x times negative 1.5x plus 250 equals max. So that's, you do that stuff for pre-calc, I'm sure, right? Like substitution. Is that what you're talking about?
Yeah, something with fertilizer.
No.
I don't know, it was really complicated, and it was like extra credit, and everyone was stressing over it.
get to one equation, one variable equals max or equals min. Because now I can take the derivative of this, I can set it equal to 0, I can solve, I can work with everything. But when there's two variables, I was stuck. So I need to take the derivative of this. To me, it's easiest to do that if I distribute first. So distribute the x through. And I didn't take the derivative yet, right? I just distributed and simplified. Now I'm going to take the derivative because where do max and mins come from? What level? The derivative levels. That's what I want to get to. The derivative here would be negative 3x plus 250. And the max, so you can think about this a couple different ways. Like when we found critical points, remember you always took the derivative and set it equal to 0? It's exactly what we're doing here. So you're always going to take the derivative and set it equal to 0. If you want to think about, okay, well, why is the derivative of max 0? Like, how does that work? Well, the max is some number. I don't know what it is yet, but it's just a number that represents the area. So what's the derivative of any number? It's 0. Now we solve that. So x is going to equal 250 over 3. Which I think I might just want to leave like that for right now. And you can leave it like that always, actually. And now you get to the part where, okay, let's figure out what you're asking. But I'll get to that in a second. Let me stop. Are there questions on what I did up to here?
Is that the max?
I'm not done yet. So what is x? It's not the max. It's this side, right? And so they phrase these differently. They might say find the width. What we just did, we'd be done. They might say find the length. That means we got to find y. They might say find the area. So you got to kind of, when you get to here, it just depends what they're asking. So what dimensions should the rancher use is what they're asking here. So the width is 250 by 3. How would I find the length? Right here. Doesn't that tell me what y is? So if I plug in there, so y is going to equal negative 1.5 times 250 over 3 plus 250. Do you see what I'm doing? You get that? And then figure out what that is. So 1.5 over 3 is a half. So half of 250 is negative 125 plus 250. So I believe this is 125. Or you have a calculator, either way. And then you can always check at the end. Like these should, my dimensions, when I put them all together, should add up to what? 500. Well, I got 250 over 3, 250 over 3, 250 over 3. So don't all the x's add up to 250? You got like a third of them in each spot. And then 125 and 125 add up to 250. 500, so it's a good check that we're on the right track there. Sometimes it'll say find the largest area that you can make. If they said find the largest area, what would I do with these two numbers? Multiply them together to get the actual area. So it just depends how they phrase it. You got to answer the question they're asking.
When it asks for dimensions, do you include units?
I mean, technically, yes, you should. I'm really bad about that. But it's multiple choice, you know, so like, it's not really going to matter. Well, on the AP test, there'll be multiple choice. I've never seen them knock off. Any other questions on this one? What'd you do here? Why'd you do this? Where did this come from? Alright, so there's like 2 or 3 different types of these. Let's have you try one like that. So number 6 is similar. Give that a shot. I think the drawings on these help a ton. They'll never make you draw. I'm never going to make you draw. I would strongly recommend it, though. answer the question I asked on number 1. If you go back, sorry, pause your number 6 for a second. I did not answer their question. What dimension should the ranger use to construct each corral? So they're not asking for this Y. They're asking for half of it. Because like they're just saying for like what would one corral be? So this would be 125 over 2. Does that make sense, the difference? My bad. So another thing you could do at the beginning if you wanted is you could go X, 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 Y, 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 Y. So now you got, then you have 4Y plus 3X equals, the last one it was 500. This one's 100. But then your area changes a little bit. It'd have to be X times 2Y equals max. So just an alternative way to do it. What?
It just depends on the phrasing of the question.
So here's my work and answer. It's 25 over 2. Same thing at the end. Like I got 25, but my Y is the whole way across, and they're just asking for this piece of it. So it's half of that. Dustin, how you doing? Tired? Anybody else in here play baseball? Besides those 2. I'm exhausted from spring ahead, much less getting up an hour and a half before school starts. That's crazy. Are you serious?
Yeah. Can't remember all of it.
Not even the first one in the building at 5:30 a.m.
This is why I give her a moment. I saw him to wake up this early and I get
Yeah.
to stay later.
I didn't wake up until about 6:45. I still thought I was gonna die. Spring ahead like wrecks me.
I saw until probably 1 or 2 when the fellas had to wake up for us.
Yeah, you like go out after, right? And then you have to get up the next day. Yeah. How many got this? Questions on it? Where'd you get this? Why did you do this? Alright, let's try another type. Let's look at number 7. So read through it. It's like a paper. You can read whatever you want. But if everyone else looked down to read,
I was
you
already
read.
in the middle of reading there, so it was going to take a lot more effort to refocus it back there.
Fair enough. I don't care where you There's more car accidents today than like any other day throughout the year. The day I spring ahead every year because everyone's like tired.
We should just get rid of it.
It really is.
Honestly, it doesn't make it sound
I
viable.
disagree there. I disagree.
I wonder what like what stall is.
There's enough farms and things around here that it's still useful.
Yeah, that's what I heard.
Farmers to on my daylight rather than my headlight.
Okay. So if I'm looking at 7, we gotta find what we need to minimize the product. So like right there, that kind of gives me a clue that I'm going to have like probably x times y equals min, or something times something equals min, because product means multiply, and min means min. A positive rational number and a negative rational number. You don't need to worry about positive and negative right now. You just need to have two numbers. So like I'm just going to call x my first number. I'm going to call y my second number. And if I do it, hopefully it won't come out positive, one will come out negative. If they don't, I probably did something wrong, because they're not really setting it up in a way that matters too much. So what I know is I'm trying to minimize the product. Well, the product of those two numbers will be x, y, and I want that to equal min. And this is where you need that other piece, because I can't take the derivative of x, I got two variables. So can someone give me an equation that would relate the two variables that I have in a different way? Okay. So the positive number is exactly 7 greater than the negative number. So I don't even care what you call the positive or what you call the negative. It's not going to make a difference. You could say x equals y plus 7. You could say y equals x plus 7. Like, no one cares which number is the first number and which number is the second number. What they want is the final product. So if one number is 7 bigger than the other, this equation has to be true, right? Alright, well that's already solved. So go back over here, take your y plus 7. Stick it in for x. So we get y plus 7 times y equals min. And I've got to take the derivative now to get to the max min level. But before, I think it's easy. Like I can take the derivative now, but I use product rule. So to avoid that, I'm just going to distribute. But that's still equal to min because I didn't take the derivative yet, right? Now I take the derivative. 2y plus 7 equals what? What's the derivative of min? 0. I don't know what the minimum number is yet, but I know that it's a number. The derivative of any number is 0. When I solve that, I get negative 7 halves. So that's like negative 3.5 ish. And then what's not ish? It is as a decimal. And then what's x? Isn't x y plus 7? And x is negative 3.5. So what's x? Positive 3.5. And notice that we got one positive number and one negative number, just like this other one, so that worked out okay. But what they're looking for is the final product. So you would multiply the 3.5 and the negative 3.5, which I think is actually easiest in fractions. Let's say you didn't have a calculator. So negative 7 halves times 7 halves would be negative 49 over 4. Or if you're using a calculator, or if you do this in your head, some of you probably can. That's negative 12.25. And again, you're looking to see what the question is. They might say, what's the positive number? Find the positive number, and you'd say 3.5. They might say, find the negative number, and you'd say negative 3.5. Or they might say, find the product. Questions there? To number 9. questions on it? They can be a lot harder, or they can be this kind of quick. We good here? Alright, let's go to number, so this is a little tougher. 11. So again, this is a real life thing. I need this much water in an aquarium. I need that much for the fish I have or whatever. What dimensions should I use with the least amount of glass? Well, that's just like trying to do it as cheaply as possible, right? That's an important thing. So, let's try to draw this. A box-shaped aquarium with a square bottom and an open top. So the bottom is square. No top. You gotta kind of draw the top though, it doesn't look like a bottom. Open. So it's not a full cube, but it's close, so that I want the least amount of glass. So this square bottom is a key phrase. So like normally what's the volume of a box? Length times width times height, right? But if it's a square bottom, can't I say like length, height? Like, these are going to be the same because it's square. You there? All right. Somebody give me an equation that we know is true using what I've done so far. Right, it needs to hold 108 cubic feet of water, right? What's the volume of this box? You're thinking surface area, I think. Super area. Volume, yeah, it does. Yeah. So it'd be length times height, right? Like, so it's length times width times height, really, but since the length is the width. So it's true that L squared H has to equal 108. If I multiply these three dimensions together, it's got to be 108 because I've got to hold 108 cubic feet of water in that box. What I'm trying to do is use the least amount of glass possible. Well, if we start thinking about how much glass we need, how much glass is used for the bottom? How much do I need? L squared on the bottom, don't I? So the area of that bottom piece is L squared. Plus, how much do I need for like this side over here? L times H. How many of those are there? There's 4 of them, right? Because like the sides and the front and the back are all going to be L times H. So normally there's 6 sides on a cube. We've got the 1 on the bottom and then 4 more here, which is 5 sides on a cube because the top's open. So we don't need to cover the top. And what am I trying to do with that? Trying to minimize it. Because I don't want to spend money. I don't want to use glass. Alright? Then I want to take the derivative of this. Like, this is the important one. This is what I want to take the derivative of, set equal to 0 and do all this stuff. But I can't right now because it's got 2 variables. So I'm going to use this one to make it so this only has 1 variable. And I want to plug in for H here. Like, to me that's easier because I'll have to plug it in 1 spot then, instead of 2 spots. So I'm going to solve the top equation for H. If I do that, what do I get? H would be 108 over L squared. The point of me doing that is so that I can plug it in down here. And now I only have 1 variable, which is what I want. So I gotta take the derivative. Let me stop, I guess. Questions where I'm getting stuff? So I gotta take the derivative of that. I'm gonna simplify a little bit first, because right now I got like a product and a quotient thing happening. So 4 times 108 would be 432. then I'm going to write it as L to the negative 1, because that's kind of the easiest form for me to take the derivative. Like, this is really 432 over L, right? Because this L and the one of the two on the bottom would cancel. So I could write it as 432 over L, but then I got to take the derivative of that. So I don't want to use quotient rules, so it's easiest if I just bring it up and make it out of the negative first. With me? Take the derivative, so the derivative of L squared is 2L. And this would be minus 432 L to the negative second equals 0. And then if you remember setting up, when we did critical points, our job was to set the top and the bottom equal to 0, right? So every time we find a critical, then the fractions didn't come up a ton, but when they did, you had to get one fraction set the top equal to 0, set the bottom equal to 0. So that's what we have to do here, because this is actually a fraction. This is actually 2L minus 432 over L squared. So I need a common denominator so that I can combine those and keep going with products. So what do I need on the bottom over here? I need L squared. Well, if I put L squared on the bottom, I've got to put it on the top. There's already one there, so now how many are there? So now, what I have is 2L to the third minus 432 over L squared equals 0. And my job is to set the top and bottom equal to 0. Well, if I set the bottom equal to 0, what am I going to get? No. I'll get 0. So my box would be 0 by 0 by 0, and that doesn't help us at all. So the bottom doesn't really matter. I do want to take the top and set that equal to 0 and see what we get there. Yeah. So I would probably, there's a couple ways. Let's add 432 to both sides, and then divide by 2. So that would give us L to the third equals 216. I skipped a couple steps there. Do we see what happened? Add 432 divided by 2. And then, everybody know, what's the third root of 216? 6. So the length is 6. But now go back and see. That's a huge part of our answer, but we're not quite done. What dimensions should they use? Well, length is going to be 6. It's a box, so the next dimension is also 6. So it's 6 by 6 by something? How do I find out the something? How do I find out age? This guy right there, the one that I wrote at the very beginning. Plug 6 in, 6 squared is 36. So 108 divided by 36. Everybody got that? That's 3, yeah. So your answer would be 6 by 6 by 3. That's like the best cube I've ever drawn. Not that anybody cares. Questions on that one anywhere? Alright, your turn. So I want you to do 3. misjudged how much we get through, so we're good. Like, if you're done with that, you got it. We're all set. There's not gonna be any homework, so we'll do the rest of it. We'll do one tomorrow, which is fine. So your test is probably that's already